With our drone flight complete and images uploaded to our computer, we're ready to start processing. As you can imagine, documenting a construction site at an international airport requires careful planning and authorization. This could be my only chance to get the images I need to create my products. So, I want to make sure I have full coverage of my project before packing up my equipment and leaving the project site. With Drone2Map working offline in the field, I'll create a 2D rapid template. Once again, I'll give my project a name and import my images. For this project, I used a DJI Matrice 200 equipped with the Zenmuse X4S camera to capture approximately 1,300 images of the construction of the Amazon Air Regional Air Hub located at San Bernardino International Airport. After creating my project, I first want to check that Drone2Map is using the correct camera parameters. Drone2Map has an extensive camera database that supports a wide range of drone cameras. I can see that the Zenmuse X4S camera has already been found and loaded into our project. But I'm not limited to using just these cameras. In Drone2Map, I can now edit or import my own camera calibration parameters, increasing the accuracy and processing speed of my project. For this project, I'll keep the default camera parameters. Next, I'll define my project area. Defining my project area will not only help me validate the coverage of my drone flight, but it can also increase the processing speed of my project. When a project area is defined, Drone2Map will only use the key points that are within the project area to create our products. The less key points to process, the faster our products can be created. I can draw the project area manually, but for this project, our client has sent us the project area as a feature class, which can be easily imported into our project. Right now, I'm only interested in the orthomosaic to visually inspect the coverage of my project area. So I'll use the Manage pane to turn off my elevation products. This will also give me faster results since I'm no longer processing unnecessary products. With my products selected and my project area defined, I'm ready to start processing. Once processing is complete, the orthomosaic is added to the map, and I can quickly see that I have full coverage of the project area. I can now confidently pack up my equipment and head back to the office for final processing. Back in the office, I can create a new project using one of the predefined templates. However, for this project, I want to create both 2D and 3D products. Since all of the templates can be customized and I already have a project created, I can simply continue working with my current project. I'll first enable the digital elevation models, which will allow me to analyze the topography of my construction site and calculate the volume of stockpiles. I've already created an orthomosaic. If I zoom in, I can see that even with the 2D rapid template, I was still able to make a pretty good ortho. However, for my final product, I would like to extract more information, such as the contents of bucket loaders and stockpiles. So I'll increase the resolution of my orthomosaic to get the maximum detail of the construction site. Next, I'll enable my 3D point cloud and integrated mesh, which will give me real-world context to my data and allow me to better communicate my findings to developers, administrators, and the public. When I toggle products, Drone2Map automatically enables or disables the necessary processing steps that are required to create the product. This makes creating products a hands-off process. If I need more control, I can manually turn on or off processing steps, or access more advanced processing options to fine-tune my project. The 2D Rapid template was configured for fast processing at the expense of accuracy and resolution. So I'll change my initial and dense processing options to maximize the quality of my products. In Drone2Map, I now have more control over how the internal and external camera parameters are optimized. These options are useful for drones that are equipped with high accuracy GPS or when using custom camera calibrations. For this project, I'll leave the default settings. With these changes, my project is now configured for high-resolution 2D and 3D products, which I can export as a template and use on future projects. At this point, I could start processing my project. However, right now, my products are being geo-referenced using the GPS information from the drone, which may not be accurate and creates inconsistent data. So I'll import some high accuracy control that was collected from a survey crew and delivered to me as a feature class. Adding control will increase the accuracy of my data and ensure that products from future flights are correctly aligned, allowing me to monitor the progress of construction over time. I'll use the horizontal geometry and altitude from the feature class and map the horizontal and vertical accuracies to the correct fields. After importing my control, I can see my data has been added to the map as well as to the control manager. The control manager provides quick access to commonly used commands for working with control and allows me to inspect the attributes of each control point. I can see that all of my control is preceded by an exclamation point. This means that I've imported control, but Drone2Map is not yet using that control to georeference my products. To incorporate the control into my project, I first need to create a link between the control and my drone images. To do this, I'll open the Image Links editor and mark the location in the image where the control was collected. I then need to repeat this process for a minimum of 2 images, but preferably between 3 to 8 images for all my control. I could do this manually, but as you can imagine, this could take some time. A faster way to link my control is to have Drone2Map estimate the location of the image links for me. After marking my first image link, I'll simply click Estimate Links. Now, all I have to do is quickly verify the location of the estimated links in each image, making any adjustments as necessary. Once I'm happy with the estimated links, I'll click Auto Link to accept their location. I've now successfully incorporated this control into my project and can repeat the process for the next control. The control manager, image links editor, and map are synchronized. So selecting control in one will automatically select it in the other. I'll just quickly link the remaining control. I can see that I now have green check marks next to all my control, which means all control has been successfully incorporated into my project. The control manager also allows me to add manual tie points. To create products, Drone2Map first identifies features in images called key points, and then matches them to the same feature in other images, which become tie points. However, all photogrammetry software can sometimes have trouble generating these tie points, such as when your drone imagery was captured over water, dense vegetation, or just doesn't have enough overlap between images. Manual tie points are linked like control points and allow me to assist the software with problematic areas, increasing the accuracy of my products. Finally, not all projects need high accuracy control. Sometimes I simply want to ensure my products align with my base map. For these projects, I can add my control from the map. Now that I've included control in my project, I can process my final products. After processing, my final high-resolution products are added to the map. If I hide the ortho, I can see my digital surface model, which models the elevation of my construction site. a shaded relief is applied to the digital elevation models by default, creating a realistic view of the terrain and allows me to identify features such as stockpiles, buildings, and even vehicles. I can also work with the digital terrain model, which has these features removed and gives me a better representation of the bare earth. I'll switch over to the 3D map to view my 3D products. What at first looks like an image is actually a 3D point cloud. If I look at the properties of this point cloud, I can see that I was able to extract over 171 million points from my drone imagery, which is quite a lot. However, as I rotate and zoom the map around this airport emergency training facility, the speed at which these points render is really great. There's little lag and I can seamlessly work with my data. And since the points were derived from imagery, the points are colorized to create a realistic scene. I can also change the symbology to view the point cloud by classification or elevation. Next, I'll look at the 3D mesh. When creating 3D meshes, it's best to use oblique imagery. However, even though this project was processed using images pointing straight down, called nadir imagery, I was still able to get a pretty good model of the project. I'll switch back to the 2D map. I'll make my ortho visible again and zoom in to have a look at the bucket loader I was inspecting earlier. This time I can see the actual contents of the bucket loader, which is carrying a pile of rubble. If I pan over to the stockpile that was too pixelated using the 2D Rapid template, I can now clearly see that it's a pile of sandbags. So now that I have a lot more detail with my high resolution products, I can start working with my data. The first thing I want to do is annotate my ortho to communicate my findings to the team. I can do this by first clicking on the Edit tab and selecting Create. This allows me to add map notes as points, lines, polygons, and text. I'll quickly draw a polygon of the sandbags to mark its location. And then add a label for quick identification. If I zoom out and pan down, I can see an area of my project that doesn't look quite right to me. If I switch over to the digital surface model, I can see I have an erosion problem at my construction site. I want to use these sandbags to mitigate erosion. So first, I'll write a quick description of the project, and then draw a polygon to delineate the project area. Finally, I'll use a line note to connect the material source to the project area for extra readability. I can publish all my map notes on a map or share them to my organization, which can then be viewed immediately in the field by the construction team. I've created a plan for my sandbags, but it would be great to get an idea of how many I have available for this project. Since I've created a digital elevation model, I can use my 3D analysis tools with a little knowledge of my construction materials to solve this problem. On this construction site, we use standardized sandbags, but they come in different capacities based on their dimensions. If I could measure one, I could look up its capacity. So first, I'll use the mensuration properties to set up my measurement tools. My sandbags are measured in inches, and their capacity is measured in cubic yards. I have the option to change the symbology, but I'll leave them as default. And I'll quickly check I'm using the correct elevation source. Now I'll use the distance tool to measure the length and width of my sandbag. Based on these dimensions, I can deduce that these are our standard 16 by 24 inch bags, which use 1 cubic yard of sand to fill 70 bags. Next, I'll use the cut and fill volume tool to calculate the total volume of the pile of sandbags. The cut and fill volume tool is calculated from the difference between the digitized feature and a base surface. This base surface is interpolated from the elevations at each vertex in my sketch. So I'll create several vertices around my pile of sandbags to make sure I have a good sampling density. Now that I have the total volume of sandbags, I can multiply 70 by the total cubic yards to estimate my sandbag count at approximately 385. All my measurements are recorded in the mensuration results pane, and I can also generate a report to share my results. In addition to Drone2Map's inbuilt analytical tools, I can export my project to an instance of ArcGIS Pro for more advanced analysis. The digital elevation models provide valuable information about the terrain of my construction site. Using the Explorer tool, I can inspect the attributes of my data. In this case, I can see that my building height is around 262 meters. However, this can be a slow process if there are many features to identify. A faster way to extract pixel information is to use the Image Information tool. After selecting my source imagery, I'll hover my mouse over the area of interest. The Image Information tool dynamically extracts pixel information at my cursor location. This allows me to quickly analyze my digital elevation models. This tool also works with the pixel values of orthomosaics and multispectral data. Another way to analyze my elevation data is to create elevation profiles. Elevation profiles allow me to visualize elevation change over a continuous distance using 3D line geometry. I'll zoom into this building I can see on the digital surface model. I'd like to know its height compared to the ground elevation, so I'll choose a cross section and draw a profile. After drawing a profile on the map, the elevation is visualized in a chart for easy analysis. Another benefit of the chart is the ability to visualize multiple profiles simultaneously, allowing for quick comparison of transects. Through the elevation pane, I can change the symbology of profiles and give them unique names for quick identification. Once I'm done creating profiles, I can save the chart to add to my report. Now that I've added some annotations and performed some analyses, I would like to share my data. However, when capturing drone imagery, I have to be mindful about disclosing sensitive data and people's privacy, especially when mapping an airport. In the bottom right of my ortho, I've noticed some personal aircrafts. Since this ortho may be used to communicate to the public, I want to exclude any details of this aircraft without compromising the context of my ortho. After clicking my source data, I'll go to the Edit tab and select the Region tool. I'll then draw the region I would like to edit, choose my editing operation, and apply the edit. Edits can be permanently saved to the current ortho or saved as a new ortho to preserve the original. Now that I've excluded any sensitive data from my ortho, I'm ready to share my data to my organization. I first want to share my map notes and mensuration results as a feature layer. I'll select the data I want to share, I'll give it a name, and I'll click Share. The Manage pane opens to the Sharing tab, allowing me to monitor the progress of the sharing job. Sharing can take some time depending on your network speed as well as the size of the file, so I'll just let that run a bit. Next, I'll quickly share the ortho and check my results in my organization. I've uploaded my data to my organization, which can be shared with my team, the public, or used in many other ArcGIS products.